What is going on, guys? My name is Hussein, and I got this question from one of you guys. When should I use UDP versus TCP to build a brand new backend application from scratch? And the first question that comes to mind is like, why did you pick only those two, right? It's like, Hussein, why are you talking about these two protocols? There are like million protocols out there. There is HTTP, there is HTTP2, there is gRPC, there is XMPP. Why? Why only those two? Because those two are the building blocks and the fundamentals of everything that comes on top. So if you understand that you pick UDP over TCP, then you will be okay to pick Quick, which is on top of UDP, or HTTP, which is on top of TCP, or gRPC, which is on top of HTTP2, which is on top of TCP, right? So if you understand how these puppies work, then you will understand how these work. And as a result, and based on that, if your backend application require low latency versus high throughput versus accuracy versus quality, you will pick the right choice, right? It all really depends on what you pick on this down basic fundamentals. That's why I really implore any of you guys, if you're into backend, if you're into backend, understand how these two puppies work. Check out this video right here, TCP versus UDP. You don't have to know how the headers look like. No, leave this at the expert network engineer. If you're a network engineer, yes, definitely you need to understand that. But yeah, if you're building a new RFC to improve TCP, yeah, you will need to understand how the headers work. But what you need to understand is, and I'm going to go quickly over the difference between TCP and UDP because I don't have an hour. I spent an hour talking about the differences. However, the difference between TCP versus UDP is UDP, you send a packet and you just forget about it, right? The only guarantee that UDP gives you is I can tell you if the packet arrived correctly or not. If I'm sending the a letter A, right, I can guarantee that I have sent an A and I got an A, right? That's it. I'm not gonna retry. I'm not gonna check if you can handle the letter A or not. I'm not gonna check any of that stuff, right? I'm not gonna do any flow control. I'm gonna do any retransmission if it fails. I don't know if you even get it or not. I'm just, as a client, I just send it. That's it. I don't do anything else. That's UDP, right? And that's very, very powerful, right? Because it does the job that most engineers want. Send the dang packet. That's it. TCP, on the other hand, it tries to solve the problems in the UDP, right? And here's what TCP tries to solve. So first of all, let me taste. TCP does that. Okay. Well, I'm about to establish a connection. Let me send. Okay. Send, which is the synchronization. Hey, server, are you even there? Let me check. Oh, I can't just send stuff. Let me establish a connection, which is something that doesn't exist in UDP. There's no connections, right? It's just bleh, just send it. TCP actually creates a physical connection between the two. And how? It actually reserves some memory on the server side. It says, hey, send. I am going to start my sequence with my packets with the number 100, right? And then the server say, okay, I acknowledge that. That means I received that. And then let's start from, I'm going to start from 500, right? And then, okay, I acknowledge that. So I'm going to start packet number 101. And you're going to start sending packet number 501. And they keep track of this sequence. This is a stateful protocol. There's a state on the server. There's a state on the server, there's a state on the client. And these state is the sequences, the stinking state sequences, and other stuff as well, right? So there is, first of all, that's the first thing, TCP. And then another thing in TCP, anything that I send, I need you to tell me whether you can handle it or not, right? I'm going to send 5 bytes. Can you handle 5 bytes? 5 bytes, a little bit low, but can you handle this? Well, yeah, I can handle up to 10. Okay. And we're going to start playing. We're going to start foreplaying. That's what I call TCP foreplay or TCP slow start. Check it right here. I made a video about it. Where even when you start, the TCP just doesn't want to send everything that it has says, oh, let me check. Does the server actually can handle this window size, that the big thing that I'm gonna send, right? If it can't, I'm gonna reduce and I'm gonna play. So the TCP starts tasting. It's like, okay, I'm gonna send you just this. Yes, send you this. UDP doesn't care. UDP just bleh, send everything at once. Who cares? That's why some firewalls actually block UDP because of this problem. So like, you're just killing our bandwidth with this, right? Another feature is acknowledgement, which is the most expensive thing in TCP. If I send you a packet, I need to know that you, sir, did you get my packet, sir? Right? And the server actually sends an acknowledgement with the label of the sequence number of that packet, telling the server that, sure, I got the packet, right? So it will send back the acknowledgement saying, I got it. So that's TCP and UDP in a nutshell. It took me 6 minutes to explain. All right, hopefully you're still there. Now, you're building a backend app. You're building a chatting app, right? So you need a server. And if you want to, why do you need a server, you might say, to build a chatting app? Well, unless you're building it peer-to-peer, you need some centralized place where you're going to send your message, right? And then another party will join the same server, and then they can exchange the messages between them, right? So if you're going to use UDP to build a chatting app, then you're in trouble. If you used UDP as its raw protocol, as is, you might send hi, and you might be lucky, and the server receives the hi, and then finds out who to send it to, and then it sends it to the actual server, to the actual client, right? Assuming there is a UDP server right here. Then the client might get the actual message correctly, if we're lucky, or a bit or two might have flipped, and you're gonna get a completely different message, right? Or I'm assuming you're gonna do some encryption. If you do encryption, then you have to do another thing, right? If it's gonna flip, and then it cannot even be decrypted, right? if the bit flipped, the cipher bit is flipped, then you will not get that message at all. So UDP with chatting app is not really great because you need those guarantees, right? However, do you need all those guarantees? Do you need TCP to build a chat app? Well, yeah. Do I need a flow control? I don't need that flow control because I'm gonna send small messages anyway, right? So I don't need a TCP flow control. Do I need acknowledgement? Not really. I can build these features on top of UDP, right? And here's where you as a backend engineer can think about this. It's like, okay, is it worth it to use TCP and get these acknowledgements and flow control for free, right? If I'm building a chat application, yeah, it's actually worth it. Because if I'm going to send these bytes, these packets, the chatting, usually it's very small packets, right? And if I send it, it's okay, right? I can use TCP because I'm going to get an acknowledgement, and I have to wait for a little bit of a time, and that's it, right? And I have to reach acknowledgement. And chatting is okay. I'm going to send a message. I'm going to wait. That's okay. I'm expecting to wait. Right? So using TCP to build a chatting app is okay. Now, when I say TCP, feel free to use WebSockets, which is on top of HTTP, which is on top of TCP. That's absolutely fine. Use pure HTTP if you don't want bidirectional. That is absolutely fine. You can use that and poll at the other client, just polls, hey, or use long polling, which we talked about, right? So you can use WebSockets, you can use that, which is all on top of TCP, which has this ability to send a message and then wait for acknowledgement, right? If you're okay with that, which you should be, building a chatting app, that's not a big deal. Building a game, however, on the other end, if I am building a multiplayer game between two parties, you can still use TCP and WebSocket and HTTP. However, be sure that there will be some lags, right? Because those lags are because of the expense of the acknowledgement, or because of the expense of the flow control and other stuff as well, right? So if you use TCP and you're playing a game where it has a very fast pace, remember, I press up, I better move up. I press down, I better move down. And this input should be sent to the other client, and that input should be applied to my character on the other client machine so that it can do that. So if there is a TCP connection between you and the server, so there is an acknowledgement there. So the server receives it, and then you wait for an acknowledgement. And the server then immediately turns around and finds what other client to send it to, and then sends that packet to the client, right? To the client, assuming there is a existing TCP connection between this other client and the server, and this client and the server. So there is a TCP connection. You can use that, right? And people do that, right? However, there is the problem of having this delay, this acknowledgement, right? And especially if you have high bandwidth game where you essentially transfer the whole state from the server to the client, which is the other flip of the coin, then you might actually express huge details, right? Imagine you're sending, let's say that you shot a building, right? This is the act, right? So the input of you shooting a building comes to the server, right? And then server say, okay, I shot a cannon at the building, and then the building exploded here. The state that the building is now exploded should be transferred to all clients, right? Because you don't know that you actually aimed at the building and you nailed it, right? So the act of transferring the state back to the clients need to be pushed down. So you'll say, oh, now the client just sent that information, right? Client A pointed the cannon at a 90 degree on this building, and then the building actually got hit, and now the building state is now destroyed, right? And some other debris hit the other building, and now the other building is now also partially destroyed. So all this state should be transferred back to the client, and this could be huge, big state, and this is called the server authoritative model, where the server is the one who decides what is the current state in every single word, right? It's like, oh, we did that, and this client Z already moved that way, right? All these changes, or everything that is state changes is pushed, and this is huge. So using UDP in that case could eliminate that latency with the acknowledgement, the TCP. But however, it's very, very, very hard to get right, because UDP is loosey, right? It's lossy. It's lossy. So now you need to really think about that, and it says, okay, if I use this, then can I afford losing some packets, some data? It really depends. The state changes. If you get the state correctly, then you're good. But if you get the state corrupted, can you do something on the client side to repair it at the application level? So can you write your backend or the client in a way to repair those packets so that I can get advantage of the UDP protocol because it's fast and it doesn't have all these guarantees, but it can also give me the content, and then I can repair it somehow, or maybe ask to retransmit that information, right? That's why a lot of people use for this kind of gaming, they use just TCP, because it's really a headache to build a UDP protocol on top of UDP, right? So using TCP versus UDP is very, very interesting, guys, on your backend app, right? So if you want these guarantees, right, then use TCP, right? If you don't really need those guarantees, those retransmission, flow control, all that stuff, then use UDP and you get the benefits of high latency and the ability to get that. But be prepared that the data might arrive corrupted. So Either try to repair it if you can, or just ask to retransmit it, right? So that if you can afford UDP, pick UDP with the video transmission, for example. It's just perfect, right? Video, images, transfer something that you are okay with it getting corrupted, or if it got corrupted, you try to repair it with a little bit of minimum effort at the application level. If you can do that, UDP is the answer. If you can't, then TCP is the answer. Even with TCP, we had a problem with HTTP, right, guys? With HTTP, what was the problem with HTTP? That TCP was not good enough for us. Yeah, here's the thing. With HTTP, guys, building a browser and web app, TCP was definitely the solution because I need all this transmission. But TCP was doing way too much for us that we don't really need this level of thing with HTTP 2 specifically, right? Because with HTTP 2, yeah, I need you to retransmit the packets. However, with HTTP 2, we have this idea of streams, right? The packets are packaged into its own layer 7 packet that has an ID called stream ID. You'll say, okay, I'm sending a GET request, tag it with stream number 7, whatever, number 7, right? And then send that. And I'm gonna send a post request, tag it with stream ID number 8. I'm gonna send another post request, stream ID 9. So you can send 3 requests at the same time. However, to the TCP layer, this is just data. This is just garbage data. It doesn't know that, oh, this is stream 1, this is stream 7, this is stream 8, this is no, it doesn't know that stuff. It knows that this is packet, this is packet, this is packet, these are packets. And guess what? If stream 9 packet received successfully, but stream 8 and 7 was not for some reason, the server will actually pause and say, hey, I received this packet, but the sequence, because they are labeled with the sequences, right? This, I don't receive this or this. I'm gonna wait for you to send all this stuff because, oh, I received packet, let's say packet number 9 is stream number 9 is actually packet, I don't know, 100, right? And then this, I receive 100, but I don't receive 90, 99, and 90, 98 or anything above that. So there must be some packets. I'm gonna wait. That's the biggest problem with TCP when it comes to HTTP 2, because guess what? This is an independent request. Why the heck are you waiting? Why the heck are you waiting? We already sent that request. Process request number 9, which is stream number 9. Process it alone. Leave it alone. So that's the major problem with TCP, right? So we reach a stage who says, wow, okay, we cannot use TCP. We need those guarantees, but they are very harsh at the packet level. We need the same guarantees, but at the stream level. So if a packet didn't receive here, resend it. But if a packet didn't, these are isolated, these stream and this stream, they are isolated, right? That's why we built Quick. So that we took UDP, which doesn't have any of the guarantee, and we built the streams idea on top of UDP. And that's where people thought, it's like, should I use UDP versus should I use TCP, right? So yeah, if you're building a low-level protocol and you don't need streams, you don't have the idea of channels, anything that TCP, and you're using raw TCP, it's probably most of the time it's a solution for you, unless you don't care if your data got corrupted at the end. All right, guys, very long video to talk about that. I know it's not a straight answer, definitely, but it really depends on your app, and that's just what I think, right? UDP in general, you can use UDP if you can afford to repair the packet at the destination, or you can afford to be corrupted, or it's okay if it got lost, right? Because I can somehow construct the content from what I have. That's the video, because video, if you lose some bytes, that's okay. You're gonna get a little bit fuzzy, but it's okay, right? But with the image, same thing, maybe. Not all of images. Some images, if you lose something, you're done, right? So yeah, Versus TCP, if you want these guarantees, again, at the raw level, then use it. But if you're building on top of the TCP, you're reusing the TCP connection, you're doing so much with it, then probably you need something like Quick, right? Or use UDP and try to do that, right? If you're using just raw TCP, beautiful, most of the time works, guys. Nothing wrong with TCP. TCP is great, right? So what are you working on, guys? What backend application you're building? What protocol did you choose? Let me know in the comment section below. I'm gonna see you on the next one. You guys stay awesome. Goodbye.